This is a lesson on rational exponents. We're going to be using rational exponents and we're going to simplify expressions. With rational exponents, we're going to rewrite things from exponential form to radical form and become more comfortable with them all around. So we're going to start off by comparing what exponential form is versus radical form. Exponential form, essentially rational exponent, you're going to have a fraction in your exponent, a number that can be written as a ratio. So we're going to have some value, which will act as the base of our problem, being raised to some power in the exponent that's going to be a rational figure, okay? So we're going to have a numerator and we're going to have a denominator. I'm going to use R and P as my numerator and my denominator. When I go and take this exponential form and I want to rewrite it in radical form, these are interchangeable, they could go back and forth. That base will become the radicand of a radical. So it's that main part that goes inside of the radical symbol. And then the R becomes the power on the inside right here, and the P becomes the index right in there. These letters I use to help me remember. R stands for the royalty or the rich people. They live inside the castle. And then P is the poor peasants. They live out in the gutter. I know it's sad, but it's just to help you remember which thing goes where. All right? Sad little story, but it's just to help you remember. Now, the radical form could also be written slightly different. We can also go ahead and take that same kind of expression, and the R, if you think about it, they're royalty, they're overseeing everything. So we could have this big parenthesis around it all, and the R can go on the outside. So these are really just equivalent statements. They look a little bit different, but they're going to be the same thing. And we're going to go bop back and forth between both forms in this lesson, okay? So next thing we have is some intense warm-up examples, and we're going to solve for X in these examples here, okay? A little intense, I know, but I feel like it's sort of good sometimes to start with something a little bit more intense there. So here I have 3 to the x times 9 to the 2x minus 5 equals 27 to the 1 minus 5x. Now, if this is a little over your head, it's okay, just follow along. The examples we do after this will seem a lot easier after we warm up. What I want to do to solve for x here is my main goal. I'm going to try to write all of these things with the same base. I want my base number to be identical for all of them. If you look, you see 3, 9, and 27 all have the number 3 in common. I could rewrite 9 as 3 to the second power. Then I could rewrite 27 as 3 to the third power. I'm going to call that a swap-opportunity. An opportunity to swap out a bigger number for a smaller number raised to a power. 3 to the x will stay as is, sorry. Then from there, 9 will be swapped out with 3 to the second power. That 2x minus 5 will stay right out there. 27, I'm going to swap out for 3 to the third power. And the 1 minus 5x will stay right there. Next, you're going to deal with all your properties of exponents here. When you would raise something to a power, and you raise that to another power, what do you need to remember? You need to remember from properties of exponents that these are going to multiply. So same here. That gives us 3 to the x again. Nothing's really happening yet. And then 3 to the 4x minus 10. We multiplied those powers together. Here, 3 to the 3 minus 15x. What's another property of exponents that we can work with right now? When we multiply like bases, I know that these are 3's. Usually you'll have something with an x. For example, just kind of going over the rules again, x to the a, x to the b. When you had like bases, you would add the exponents. The one we had just done, x to the a to the b, you would multiply your exponents. So that's what I'm using down here, okay? I'm going to add my powers now, my exponents. So it's 3x plus 4x minus 10 will give us 5x minus 10. And the other side, nothing could really happen there. Now the next thing we're going to use is going to be called the one-to-one property. 3 to this power right over there equals 3 to that power over there. That means the powers must be equal to each other. Since they have the same base and 1 on each side, we're going to use the 1-to-1 property. You're not dividing by 3, you're not taking a root, you're not subtracting 3 or just canceling it out. That's not what we're doing. So it's the one-to-one property. We'll get more into it in future lessons. 5x minus 10 equals 3 minus 15x. I'm going to add 15x here, that gives us 20x. I'm going to add 10 over here, that gives us 13. Squashing a little bit, but x equals 13 over 20. There it is. We're done. Another example, very similar. Again, I told you these are intense, so just sit tight, hang in there, and we'll get through it together. Now I have some division. Well, what were the rules with division? If you had x to the a over x to the b, what were you allowed to do? You would subtract your exponents. You could do it like that, or you could put them in the denominator and subtract the other way, whatever way you prefer, but this is fine. So these are already like bases, so I'm going to go ahead and subtract my exponents. Make sure if you were subtracting this were a binomial or a trinomial, make sure you distribute that minus sign, okay? Next step will be then 2 raised to the, really it's 3 minus 2x minus 3, but this minus 3 and that positive 3 are going to cancel out. Here, 32, we're going to swap opportunity that. That's really 2 to the 5th, 7x minus 8. Now, I'm going to rewrite this as 2 to the negative 2x. I'm going to multiply my exponents like we just did earlier. 35x minus 40. Next, I'm going to bust out the one-to-one property. So the one-to-one property is telling me I have negative 2x equals 35x minus 40. Let's subtract 35x, negative 37x is negative 40. A negative on each side. Again, that's really one-to-one property right there. Getting rid of that negative. We have 1 on each side, one expression right there, gone. Just kind of ignore it and concentrate on the rest of the material. X equals, divide by 37, 40 over 37, and then we're done. No calculator necessary. All right, no calculator needed. Next example in our intense warm-up is this one right over here. What number can I rewrite all of these as a smaller base to a power? I'm going to swap opportunity with 2's. 8 is 2 to the 3rd, to the x squared. 64, 2 to the 6th, to the 2x. 16, 2 to the 4th, 2 to the x, just 2 to the x. Going to multiply? I'm going to multiply. 2 to the 3x squared times 2 to the 12x equals, well, I have like bases, I'm going to add the powers. 2 to the 4 plus x. Same here. 2 to the 3x squared plus 12x. One-to-one property in action right now. I'm going to set those powers essentially equal to each other. There's a 2 on each side raised to a power. Those powers must be equivalent. So from there, 3x squared plus 12x equals, I'm just going to write it as x plus 4. Now what kind of equation are we working with? This is from earlier lessons. This is a polynomial. It's a quadratic. In order to solve this, we get it equal to 0. Factor and solve using zero product property. Subtract the x, subtract the 4. 3x squared plus 11x minus 4 is 0. This does factor. If you struggle factoring, that's on you. Press pause, work on that, and you gotta get better at it and make time to improve. So we have 3x squared, oh, no x squared, sorry. I'll write that out in a second. 3x and x, I'll have 4 and 1. Now, outer and inner, I need an 11, so I'll have a plus and a minus. Set each equal to 0. 3x minus 1 is 0. So x has to be 1/3. There's one answer right there. And here x has to equal -4. So there's my second answer. So kind of, like I said, an intense warm-up right here. But, sorry, I'm just going to take care of that. So we're going to take it from here with some, actually, hopefully, easier examples. Alright, so now these should seem a little simpler. You have a bunch of ways you can do this. You could either rewrite this from being an exponential form. We could rewrite this in radical form. So you can look at it as 216 to the first power in a cube root. That's fine, but I prefer swappertunities. 216 is really 6 to the third power. And then I have that 1/3 power out there. Properties of exponents. What's 3 times 1/3? That's just 1. So final answer is 6. Boom, done. Here, properties of exponents. I'm multiplying like bases. So what do you do with your exponents? No, that does not become 49 right now, okay? I mean, sure, there's other ways you can do it, but right now I'm dealing with properties of exponents. So you'll have 1/2 plus 1/2. 1/2 plus 1/2 is 2/2. I know I'm being extra, just clarifying all the rules, which is 7 to the first, or 7. I don't have like bases. I do have like radicals. They are fourth roots. I could multiply a different way. However, I'm going to practice on different characteristics right now. So rewriting these as both 5 to a power, 5 to the 1/4 times 125, swappertunity. 5 to the third to the 1/4. Still 5 to the 1/4 times 5 to the multiply 3/4. We have like bases. So I'm going to add my powers. What's 1/4 plus 3/4? 4/4, which is 1. So the answer is 5. Next example, swappertunity. Now 64 is 8 to the second. 64 is also 4 to the third. And 64 is also 2 to the sixth. I'll always pick the smallest base. It makes things easier to clean up in the long run. 2 to the sixth to the 1/2. Which becomes 2 to the third, which becomes 8. Yes, you could have gotten that same answer in a different way, but just moving through this way so I could practice working with breaking down my numbers as best as possible. Number 5 is just like number 7. Now what if I did this a different way? Could you change these both to the square root of 11 times square root of 11? Sure. They're both square roots. It's really the square root of 121. And then that equals 11. Or you do what we did earlier. 11 to the 1/2 plus 1/2, 1, done. Either way, the answer is 11. This was a little strange because you can't write 12 as 3 to a power, but we can play with this a bit. So 3 to the 1/2 I'll leave alone. 12 is really 3 times 4. 3 is already prime, but 4 is really 2 squared. That's 12 to the 1/2. So it kind of reminds me of how we were simplifying our radicals. When you have a product or a quotient, not a sum or a difference. Rewind and watch and listen to that again. When you have a product or a quotient, not a sum or a difference, this power can just be given to everybody on the inside through multiplication of the exponents. Not when it's addition or subtraction inside. So the next step, I have 3 to the 1/2 times another 3 to the 1/2 times 2 to the first. 3 to the 1/2 and 3 to the 1/2 is 1/2 plus 1/2, 3 times 2. Final answer, 6. Are there other ways to do it? Yes, but like I said, I'm focusing on one style right now. Next, converting between exponential and radical form. All right, nothing too crazy here. Convert to radical form. That's exponential. That's my royalty, upper class, and that's my peasant, lower class. Radical form, building the castle. Who lives in the gutter? 7. Who gets to live inside? The royalty. Done. In order to do this, I need to get rid of the negative, and I should also really get rid of the decimal. So first, I'm going to rewrite this as y to the 3.5 in my denominator, because I have a negative exponent, so it's 1 over y to the 3.5, which is also equal to 1 over y to the 3.5 as a decimal is 7/2. Sorry, it's a little squash. That's 7/2. So, what will this be in radical form as my answer? Here's the radical. It lives in my denominator. That's y to the royalties inside, peasants out there in the gutter. 2's for index, you don't have to write, because when it's blank right there, it goes, it's implied that it's a square root. Okay? Now, convert to exponential form. So this is an invisible 2, just like we just talked about. So a to the upper, lower, done. This is overseeing the whole kingdom. It's really the royalty. There's that peasant again. So b to the 3/5. That's it. That is it. Done. So the answers to these are right here. Okay? Continuing. Combine and simplify radical expressions. So a mix of a few more examples. So what do we have here? X is a common base, so that's a good thing. I want to rewrite this using properties of exponents as best as I can. I cannot simplify these radicals. I don't have anything to take out. They're different indexes, so that could become x to the 3/4. This can become x to the 2/8. X to the 2/8, the 2/8 actually can reduce. I can reduce that to 1/4. That makes things nice. When you divide, what's the rule? We subtract our exponents when we have a common base. So what's 3/4 minus 1/4? That will be x to the 2/4, which is x to the 1/2. So you can leave it like that. Or we could also write that as the square root of x. Either way, it's acceptable. So that would be marked correct, and that one as well. Okay? Next, I'm going to use exponents. 3 to the 1/2 times 3 to the 1/4. I want to add my exponents. That becomes 3 to the 2/4. I need a common denominator. 3 to the 1/4. So my common denominator would be 4. Add them up. 3 to the 3/4, and nothing wrong with that. Leave it the way it is. This one, similar to this one. X to the 3/2 over x to the 2/3. I want to subtract my exponents, but again, I need a common denominator. This becomes x to the, what's my common denominator going to be? It's going to be 6. So times 3 times 3 times 2 and times 2. So I get x to the 9 over 6, x to the 4 over 6. That becomes x to the 5 over 6. That's all. Subtracted our exponents and we're done. Next, 7 to the 1/2 times 7 to the 1/3. That's 7 to the 3 over 6 times 7 to the 2 over 6. Final answer is 7 to the 5 over 6. And we're done. Alright, next set. What is each number in simplest form? Using the same things we've been using. I'm going to do a little swap-opportunity. 16. Well, that's replaceable with 2 to the 4th power. And then negative 2.5, I'm going to make that a fraction. That's negative 5 over 2. You have many, many ways you can do this. I'm going to multiply my exponents. I will get 2. 4 times negative 5 over 2. I'm going to reduce. 4 over 2 is 2. So it's 2 to the negative 10. That becomes 1 over 2 to the 10, which is really 1 over 1024. Done. Next example. Can I have a swap opportunity right here? Can I rewrite negative 32 as 2 to a power? I can replace it with negative 2 to the 5th. That's negative 32. That's raised to the 4/5. What's 5 times 4/5? Times is also the word of. What's 4/5 of 5? It's 4. So I have -2 to the 4th. And anything positive or negative to an even power is positive. And 2 to the 4th, well, you should know it by heart. That's 16. We just dealt with 32, which was 2 to the 5th. Now I have it all raised to the -3/5. 5 is really 5 over 1. These 5's reduce. I have 2 to the -3rd, which is really equal to 1 over 2 to the 3rd. Final answer, 1 over 8. That's it. Done. Couple more. 16 again. That's really swapped with 2 to the 4th to the 3/4. 4 over 1. 4's are gone. 2 to the 3rd, which is 8. It's easy when someone's telling you what these numbers to a power are. If you don't know them, that's where you're going to struggle. I suggest you make time to learn them. Okay, couple birds at once with one stone. I'm going to replace 9 with 3 squared. I'm also going to deal with my negative exponent by bringing it to the whole expression to the denominator. And I'm also going to change that to 7 over 2. And that gives me 1 over 3 to the 7th. And I don't know what that is by heart. That's pretty big. I'm going to leave it like that. Done. Next, what is each expression in simplest form? Now we're combining variables and constants, all right? Everything needs to be handled right now. -8, this power goes to everybody. It goes here, and it goes here, okay? To all of these expressions. So -8 to the 2/3 times x to the 2/3 times xy to the 1/2 to the 2/3. -8 is the same as -2 to the 3rd to the 2/3. I know it seems like a lot of work now, but it all levels out. X to the 2/3, multiply my exponents, 2's cross out, so it's really xy to the 1/3. 3's cross out, what's -2 squared? 4. Here's the x to the 2/3. These are both x to the 1/3 and y to the 1/3. Final answer, 4. X, y to the 1/3. Might take you a little longer. You might have to pause and redo. You might go a roundabout kind of way, but you'll get there, okay? Here, this power is going to go to each of these, but I'm going to do a little work at once. So 16. It's 2 to the 4th to the -3/4. Y to the -8 to the -3/4. That's 2 to the -3rd. That's y, negative and negative, gone. 8 over 4 is 2. 2 times 3 is 6. Y to the 6th stays in the numerator. 2 to the 3rd comes down here. Final answer, y to the 6 over 8. That's it. We're done right there. And the last two. For these two, I have 8 x to the 15th, all to the -1/3, and then I have a 9x, 4th root of y to the 3/2. Okay, 2 to the 3rd is 8. That's being raised. Both of these things are going to get this attention from this. -1/3. Here, if you want to do it all at once, it's really x to the -5th, 2 to the -1, x to the -5th. What does that become? There's a 1 on top, 2 x to the 5th. Done. 9 is really 3 squared, and that is being raised to the 3/2. X to the 1st to the 3/2, y to the 1/4 to the 3 halves. Those 2's are gone. 3 to the 3rd, 27. X to the 3 halves. Y, careful, this one is 3/8, nothing reduces. Alright, so that's the end of these examples, and I hope you understand a little bit better now.